Hello and welcome to Algebra 2 tutorial. In this video, we're going to take a look at the sine and cosine functions as functions this time and turn them into graphs and equations. We've always looked at them so far as ratios of triangles and just as values. Now we actually take a look at them as input and output functions. So first we're going to take a look at the sine graph and turn that into a graph. So we're familiar with the sine values on a unit circle, hopefully. So just again to remind us about that, our sine values are the y values, all of these. And so the questions we could ask ourselves are, hey, what is the value of sine of pi over 2? And so pi over 2 is straight up, right here at 90 degrees, and so sine of pi over 2 is equal to 1. Well, now we're going to take this angle as our input, and we're going to think of this value over here as our output. And we're going to turn this into an actual function. So to do that, we're going to first make a table. So for our table, we're going to have an input and an output. And so the numbers that go inside the sine function are angles. So our inputs will be angles. And our output is just the number. It used to be a ratio, a fraction, so we'll think of that as our ratio. But what we're really going to start to think of this as an x value and a y value. So we're going to turn this statement into basically y equals sine of x. All right. So our input, our first angle down here is 0, and the y value is 0. Then our next input, this angle here, you can think of this as degrees or radians. Degrees is probably easier, so let's stick with that for right now. That is 90 degrees. And so our sine value is 1. It's the y value. Then we keep going. My next angle here, this angle is 180 degrees. And the sine value is 0. And then 270 degrees, the sine value is -1. And then if we go a full circle back 360, we get back to 0. Now that can keep going. You are certainly allowed to keep going around in this circle, but the pattern will stay the same. Sine goes from 0 to 1 to 0 to -1, back to 0 to 1, 0, -1, 0. And we have what is called a periodic function. So our graph, if I were to put all this on a graph, one full period here from 0 to 360 degrees. And so we often think of these functions in terms of periodic functions and how long one period is. So this period is 360. And just like around the circle there's sort of 4 main points, we break this up into 4 pieces. So the middle is 180, then 90, and 270. And yes, it does go on by continuing to add 90 degrees. So this one would be 450 would be the next one. You just keep adding 90 degrees. And this, our y values go down to -1 and up to +1. And so now we're ready to start drawing this graph. Get us a different color here. So at 0, we are at 0. And then 90, we're up at 1. 180, we're back to 0. 270, we're down to -1. And 360 back to 0. And if we kept on going, we would just follow this pattern again. So the next one would be at 1, then at 0, and then at -1. It would just keep following that pattern. And no, it's not straight lines. These are curves. So when we connect them, make it as curvy as possible there. And that is the sine graph right there. Make that look just a little nicer. There we go. And it does continue the wave here that way, and the wave does continue on this side forever as well. So we take this ratio of triangles, this sine function, here is the actual equation, and it makes a wave. Pretty cool that triangles turn into a wave there. All right, so that's sine. So now we're going to take a look at the cosine function, and you're going to see it's actually very, very similar. So again, we're going to take the cosine function and turn it into an actual equation, y equals cosine of x. And our inputs are again going to be our angles, those are our x's, and our outputs will be those ratios, the points along the outside of our unit circle. So we're going to start with an angle of 0, then do an angle of 90, 180, 270, and we'll get for our table at least one full circle all the way around to 360. All right, now for the values of cosine. Now cosine are the x values. So we're looking at all of these numbers here. So cosine of 0 is 1, then 0, then -1, then 0, and back to +1. And if we did keep going, you would just continue around the circle. The next one would be 450 degrees. That would be back to 0. All right, let's draw this graph now. So again, we think of one complete circle, one complete period is 360 degrees, and it breaks it up into 4 pieces. So if I cut it in half, and then cut it in half again. So 90 plus 90 plus 90 would put me at 270. That will be one complete period. So let's draw this one. So again, we're going between 1, 0, and -1. So my biggest y value right now is 1, and my smallest y value is -1. Cosine this time, however, starts at +1. So we are going to start up here. And then it goes to 0, and then -1, and then back to 0, and then up to +1. And so if we kept that pattern going, the next one would be here at 0, and then down to -1, etc., etc. And we again see our wave happening. Let me connect those up. Something like that. And it does keep going in both directions, so the wave goes that way, and the wave goes that way. But we again get this wave. So the big difference here between our sine wave is cosine starts up here at 1. So over here, the beginning of our circle is at 1. That's cosine. And if you remember, the sine wave that we did before this started here at 0. And that's where the sine wave was. So it looks very, very similar, but they just start in different places because cosine starts at 0 and cosine starts at 1 and sine starts at 0. All right, now that we have these two equations, these two graphs, these two functions, we do what we always do with our functions. We transform them. We're going to move them up, down, left, and right. We're going to stretch them. We're going to shrink them vertically and horizontally, all of our transformations. Now, thankfully, we're not going to do all of them right now. This does get fairly complicated, but we can start this process. So we're going to focus on the a value in front and the c value in the back. So if you remember, with any function, the a value is a vertical stretch or a shrink. All right. Now, it could also reflect. Remember, it can reflect over the x-axis as well if that value is negative. All right. And the c value, if you add a number on the outside of a function, that will translate up or down. Okay, so that was happening when we did parabolas. If we did exponentials, that's what happens when you change those two numbers. Now, when we do it with our waves, with sine and cosine, those transformations have special names. So if you change the c value, if you move a wave up or down, you are changing the midline. So there's an imaginary line through the middle, and that's how we measure the vertical translation. All right. Now, the a value, we have a special name for that as well. When a wave gets taller or shorter, that is called the amplitude. The amplitude. So same characteristics, but they have special names for trig functions. All right, I want to show you those, what they look like really quick. So here I have a sine wave, and you can see my equation over here. It's got an a value. Right now the a value is 1, and it's got a c value. Right now the c value is 0, and so plus 0 doesn't change anything. There are numbers on the inside, and we will change those later. But first the amplitude. So if I make this number bigger, it will vertically stretch my graph. You see there. And what is called the amplitude is changing. And the amplitude is shown right here. The amplitude starts in the middle and then counts up to the tallest peak of the wave. It could also go from the middle to the lowest peak of the wave as well. That distance is 3 right here. It's also 3 down here. So that is our amplitude of 3, and you can see there it's the number right in front of our equation. So that means the wave is going to go up 3, and the wave is going to go down 3 units from the middle. Now the c value. So if I change my c value, so you can see that moves the graph up and down. So if I move it right on the 2 there, so now my equation has a plus 2 at the end, and now we have this midline, this line through the middle of the wave, and it's up here at y equals 2. And so from that 2 value, I go my amplitude up, so 2 plus 1, 2, 3 lands me at 5. Or if I start at that 2 and then go down 3, minus 1, minus 2, minus 3, puts me at negative 1. So the wave still goes up 3 and down 3, but that makes it land at positive 5 and negative 1. And so those are the two transformations we are going to take a look at: changing the amplitude and changing the midline. Now there's one more thing we should take a look at. What happens if your amplitude goes negative? So it gets smaller and smaller and smaller, and then it flips if it becomes negative. The graph has been reflected. So now sine still starts in the middle, but instead of going up, it's now going down. All right, the amplitude is still the same. It's just going in a different direction now. So that's something to keep aware of, is that negative value flips the graph. All right, let's take a look at how that actually works with some examples. So now that we've seen the transformations, let's do that. So there's two ways we want to make sure we can identify and describe transformations.